Hello, everyone. Well, hope you have been having a great reinvent so far. Let's make it a notch better with a cool session on building log analytics solutions on AWS. My name is Pranav Nambiar. I'm a senior manager on AWS. Also, I have with me Tommy Lee, who is a senior software architect at Autodesk. Together, we're going to talk to you about various factors you need to consider as you think of building a log analytics solution. Our goal is to provide you enough insights so that you can make informed decisions as you think about log analytics at scale. We have packed the session with a lot of content, and so we won't have time for a Q&A in this 1 hour. However, both Tommy and I will be around after the session, so in case you have questions, hold on to them, and we can answer them for you separately. Sounds good? So are you all ready to get started? Awesome. OK, so let's get started. I thought the best way to get started would be to just talk about some of the key situations we face while dealing with logs. Let's have a show of hands. How many of you have dealt with situations where you actually felt you don't have enough data or logs to solve a problem? Wow, pretty much all of you. Absolutely, right? All of us have been in that situation. And how do we respond to that? The instinctive reaction is, open up the floodgates. Let's log everything. Let's make sure we don't have any case where we don't have data. That's literally what most of us do. Just log. Just keep logging. Storage doesn't cost as much, so let's have answers ready. But that brings us to a new situation. Let's have a show of hands. How many of you have dealt with situations where you feel you have a lot of data, but you really don't know if you're putting it to good use? OK, pretty much all of you again, right? Let's look at it one step deeper. Frankly, when you build any solution, even if it's a simple website, you've got a lot of different components. When you go with the strategy of logging everything, logs can pile up easily. It's going to be much more difficult to handle it until and unless you have a clear, efficient log analytics solution. That brings up to our next situation. How many of you have actually wondered, are you really operating efficiently with your logs? I'm sure pretty much all of you, with the heads nodding here and there. This is the core situation that we face mostly, because these days, when it comes to logs, people are figuring out ways to do log analytics, but it's not always the more efficient solution. Let's face it. When you look at logs, here's a typical HTTP web server log. It's not easy to digest a log. It's unstructured, and think of it at a very high volume. What happens? It's not easy to process it. You could follow a traditional approach. You could run your grep commands or your scripts and process it, take hours. It's possible that you make errors in that. Even a small spelling mistake could actually cause issues. Or you could actually use a smarter approach. You could use a product like Amazon Elasticsearch Service and actually build more informative dashboards. You have a better programmatic interface to actually get insights at your fingertips in real time. So this session is all about the smarter solution. It's about what you can do with Amazon Elasticsearch Service and what are the things that you need to note. So what I'm going to do is I'm going to start off by giving you a high-level overview of Amazon Elasticsearch Service. We won't dive too deep into that, but we'll focus more on the factors you need to focus on while you're building log analytics solutions. And then we'll have Tommy, who's going to come over and tell you about the Autodesk story. They went through a similar process too, wherein you have a lot of data. Now, how do you operate efficiently? And he's going to talk about all the insights they have gained from Autodesk to actually, in terms of to build their log analytics solution. So let's get started. Let's start with the first main question. What is Amazon Elasticsearch Service? So I'm sure most of you are familiar with Elasticsearch as such. So Elasticsearch is a popular open source solution for both log analytics and full text search. Amazon Elasticsearch Service offers you a fully managed solution around that. It takes care of the heavy lifting around deploying, scaling, and managing Elasticsearch and Kibana so that you can focus on your log analytics solution. There are a number of benefits of Amazon Elasticsearch Service. First of all, it's easy to use. You can literally get started in minutes. Just a few clicks, you can get a cluster set up, and you can ingest data and get going. It's also highly scalable. The number of instance choices that you have, we'll talk about it in a bit. You also can easily scale up or scale down depending on your workload situation. It's also secure. The number of security features, we'll touch upon a few key ones. You have IAM, you have VPC, you have encryption at rest, and in transit, a number of different options. It's also highly available. It offers you cross-zone replication, so that even if a zone goes down, you still have availability. It also takes care of automatic failure recovery from hardware failures. It's open source compatible with your open source APIs. So even if you're using self-managed Elasticsearch, you can easily lift and shift it to Amazon Elasticsearch service. And last but not the least, it works well with several other Amazon services. And so it's easy for you to ingest data, get it into Amazon Elasticsearch service, and run analytics on it. The number of use cases where people use Amazon Elasticsearch service, I'm sure you folks deal with many different use cases. At a high level, people use it for troubleshooting, root cause analysis, application performance management, application monitoring, security intelligence. You could have IoT or mobile level metrics or application tracking. You could do business analytics, clickstream analytics, and so on. There are many, many different use cases for it, and I'm sure you'll find even more use cases as you look at it from your business perspective. For the sake of this session, we're not diving deep into the use cases part. Let's focus more on the architecture side of things. At a simple level, the core component of the architecture is the Amazon Elasticsearch Service domain. The domain consists of all the hardware and software components that you need to run an Elasticsearch cluster. So you set up the data instances that you need, which host all your data. You can optionally have dedicated master instances. There's already an ELB fronted in front of your data instances, which does the load balancing. You also have IAM for access control. And then you can interface with your domain, either via console, SDK, CLI, or CloudFormation. You have CloudTrail and CloudWatch for monitoring and audit. Now, in general, how do you go about operating this? You just simply go ahead, create your domain. You pick the kind of instances that you want, ingest your data, and get started. It's literally in minutes you can get going. But now let's talk about actually, OK, so it gives you a lot of functionality, makes things a lot easier from different angles. But let's talk about how can we actually put it to good use, especially when you're building your log analytics solution. That brings up to the next part of this discussion, which is what are the factors that you need to consider while you're building a log analytics solution? So let's start with the log analytics solution at its simplest level, and then we'll build on top of it. So at its simplest level, you have a data source. You ingest data to your Amazon Elasticsearch service domain, and then you can either visualize data using Kibana, or you can query it programmatically if you want to a consumer, right? That's at the simplest level. But reality is way different from here. In reality, you have many data sources. You've got a number of different consumers who want to interact with that data and get the data in real time. And now how do you build a log analytics solution to cater to all these needs? There are two common models that we see. The first model is the decentralized model. You have a problem, you feel you don't have data, okay, go ahead, set up your own log analytics solution, just build up your own Elasticsearch service domain and set it up. You have your data source, ingest the data, query it however you want. This model gives you flexibility. If you have many teams in your organization, each team can have their own, they can be on their own, they can just run with it. It helps you optimize those domains for those requirements. You can have their own separate security policies. It also kind of isolates the area of failure, because at the max, you'll be only failing one domain, let's say, due to some issue, while the others are still operating, and so on. So there are benefits to this model. But let's go back to the three scenarios we talked about. Firstly, we said, OK, do I have the data? And then you figure out, OK, I don't have, let's log everything. This is a situation that you get into when you say, let's log everything. Everybody logs data into their own domains. Then you come to the third situation, and you start questioning, hey, am I operating efficiently? That's where things are a bit tricky. Because when you have these multiple solutions, you don't always drive the best utilization. That brings up to the next model, which is more of a centralized log analytics platform to which you ingest data from your multiple sources, and you can read that data across your different consumers. You need to track and handle access control because, yes, the different kinds of consumers, different kinds of data sources, not everybody needs access to everything else. Now, this model reduces your management overhead. You're not having n different domains set up. It also helps you enforce standards, let's say security standards or compliance. You have a specific area that you can focus on. You can have a dedicated team that actually looks into it, and you can build it so that it can actually cater to all the requirements. It gives you better utilization, and in the sense that you can have 10 different domains with a lot of data hardly being used, or you could actually, if you're using it in a single domain, you might be able to leverage the resources better, because if one team is not using enough data while the other team is using, that's fine. It's still utilizing that resource. So for the sake of this discussion, we're going to dive deeper into a few factors that you need to consider as you're building such a solution. For the sake of time, I'm going to focus on 4 key factors, each of which I feel are very critical as you build log analytics solutions. Let's start with the first one. The first one is ingesting your data. The second is optimizing your domain. Third is securing your domain. And last but not the least is scaling. We'll talk about each of these, and I'll try to give you some key tidbits that you need to focus on as you're building this. Let's start with ingesting data. When you talk about a typical ingestion pipeline, there are multiple parts to it. You have a data source, you collect the data, you may buffer it, you need to transform it. Elasticsearch needs JSON, so if a data source doesn't give you JSON, at least you need that transformation. You might have further business logic to do more transformation, and then you need to deliver the data to Amazon Elasticsearch Service domain. Now, for each of these phases, there are a number of different technologies, and here's a few examples. So you could collect the data by running a Kinesis agent on your box. You could have CloudWatch agent. You could run FluentD. You could have your own custom application do that. You could do it with Logstash. You could do it with Beats. You could buffer the data using Kinesis or CloudWatch logs. You could use Redis or Elastic Cache. You could use S3 if you want. You could use Logstash, RabbitMQ. There are tons of options. Again, with transformation, you can use Kinesis. You can write a Lambda function to actually transform. You could use CloudWatch. You could use Logstash. And similarly, to deliver the data too, there are different technologies available. Kinesis DataFirehose can easily do that for you. You could do that explicitly through your application. You could write a Lambda function. Now, if you just look at this, there are many permutation combinations to actually do this, right? Look at it as Lego blocks, and you can assemble them in any different form. What I'm going to focus on is provide you 2 key patterns that are pretty useful and handy when you're building a log analytics solution. The first pattern is what we call the Amazon S3-based data lake architecture. So the idea here is that you collect the data from your various data sources and dump them into S3. S3 triggers the S3 events to which you trigger a Lambda function, which takes care of transforming the data as needed and writing it to Amazon Elasticsearch Service. Now, the biggest advantage here is you have a highly durable service in the form of S3 that houses all your data. You can easily pump this data to several other services. Amazon Elasticsearch Service is one of the options. It's low-cost storage for that, and you can always revert back to that storage as needed. Now, in your case where you have multiple data sources, multiple consumers, this is a great model. You can make sure all the data is in S3, and S3 forms a data lake, and then you can consume it. So this is one very handy tactic. The other key one is using Kinesis DataFirehose. The one option is you have data sources, you run your Kinesis agent on it, which writes the data as and when it comes to the Kinesis DataFirehose. And from the Kinesis DataFirehose, you write it into Elasticsearch. There's a direct integration with Amazon Elasticsearch Service. You could write a Lambda function to run transformations on that data, which is residing in the Kinesis Firehose, and change it however you want before it's written into Elasticsearch Service. Also, you could actually identify those data components that are not meeting your requirements. Maybe the transformations failed. You could put it into a different S3 bucket if you want for debugging later. If you feel, hey, you need some kind of a data lake, you want to actually save the original data, maybe there's a compliance need, or maybe you want to actually retain it, you could always direct the data to S3 as well and store it in S3 while the data also goes to Amazon Elasticsearch Service. So this is another very powerful, scalable pattern, especially when you have very high ingestion rate. Kinesis can help you with the buffering. You can do the transformation with the Lambda and get it through. Now, these are the two key things that I would like to, you to consider as you're thinking of log analytics. With that said, let's actually move on to the next step, optimizing your Elasticsearch Service domain. The first key part that most folks actually think of is tenancy. Should I use one bulky index, or should I use multiple indices to actually accomplish the task? Now, with multiple indices, you could have dedicated indices per use case. You could have different rotation patterns. You could have different security credentials on those indices. You have a lot of flexibility. You can even add more indices to just scale. But then you have the same problem. When you have too many indices running on the domain, you run the risk of having too many shards and actually having performance issues. So you may not always be that optimal. So fewer indices can actually provide you better optimization. However, if you have just a single index with all this data, you're forced to query that index even if you want just a portion of data. So that's where the trade-off comes in. You need to figure out a balance where you feel you have the right optimization, where you have enough indices to take care of the task rather than creating thousands and thousands of indices. Now, that's part one. The other key part is sharding. What we have seen is sharding is one of the primary reasons because of which people face inefficiencies and performance issues. So there are two tips I would like to give you. First of all, try to make sure at any given time the number of active shards is equal to the number of vCPUs you have in your cluster. So for example, the chart here shows you, when you're ingesting at a high rate, for an M4-2XL, which has 8 vCPUs, at 8 shards, it's able to deliver maximum parallelization. If you have fewer than that, you're not utilizing it well enough. If you have more, it's actually overloading it, and anyway, it's not getting utilized well enough. So that kind of helps you attain the maximum throughput. The other part is, when you have multiple different indices on the same domain, try to ensure that you don't have fairly varied shard sizes. Because when the shard sizes are skewed, it's actually going to make things imbalanced in your cluster, and that's going to run into further issues, performance issues, JVM memory pressure, and so on. So that's the second tip that I would like to give you, something for you to consider as you're thinking of optimizing a domain for scale. Now let's move on to the other part, securing your domain. So if you're getting multiple data sources, multiple consumers, a key part is how do you secure it? Of course, Amazon Elasticsearch Service has a bunch of options. It's got IAM-based access control. You've got CloudTrail for auditing, CloudWatch for monitoring. You've got different options. But I'm going to give you two key security tips that you would want to use, security features that you would want to focus on. First one is VPC. With VPC, you ensure that your data is not going over the internet. It's within the Amazon network. It also has the added benefit that you can actually control access based on IP addresses, and you restrict the surface area of access to your cluster. And to top it all, you don't pay any extra cost just to enable VPC on Amazon Elasticsearch Service. It's free. So this is something core that you would want to consider no matter what kind of domain or use case scenario that you're actually focusing on. The other key one, which we launched recently, is integration with Amazon Cognito. So when you use Kibana, typically, I'm sure some of you might be using a signing proxy. But with Cognito, you no longer need to do that. You could actually set up your user pools and identity pools in Cognito to manage the different users that you have. You could integrate with your enterprise identity providers. That way, when you make a call from Kibana, it hits Cognito and maps your identity to an IAM role through which it actually invokes Amazon Elasticsearch Service domain. So this is the other area that you might want to consider as you're thinking of security for your Amazon Elasticsearch Service domain. Now, with security aside, let's look at the last big factor, which is scaling. Now, all of us start with a small model for scale. We always think, OK, let's start small, and as and when needed, we need to add more, and we need to scale up. Now, it gets a bit tricky and difficult if you don't plan it well and if you don't consider the right aspects. So again, I want to give you two key tips as you're thinking of scaling your Elasticsearch Service domain. First and foremost, understand your bottlenecks. So we've seen a number of people who actually just, when we think of scale, it's OK, let's add a few more instances, get going. But many times, you need to understand, is it between disk, CPU, or memory? Where exactly is your bottleneck? And so you need to optimize. You need to scale on that angle first. The other part is don't ignore your master nodes. So the master nodes actually help in orchestrating the data. If you have too many shards in the cluster, it's actually going to get overwhelmed, and it's actually going to disrupt the performance. Many times, folks just look at the data nodes, ignore the master nodes. But you need to consider the master nodes as well when you're thinking of scaling and the bottlenecks that you need to handle. Now, you might be wondering, OK, so if that is the case, which instances should I use? So there are a number of instance types that Amazon Elasticsearch Service supports. You could use the T2 instances for dev test workloads. It's not meant for production level scale. You could use the M kind of workloads for general purpose scenarios where you don't have that heavy querying or that heavy indexing. You use the R series, which is very memory optimized when you have memory intensive workloads. Especially you have very high query rates, immense aggregations, or complicated queries. You could use the C family when you need a lot more processing and you have a lot more concurrent requests or high indexing rates. And you can use ICE when you have high IOPS requirements or higher storage requirements. The I series, in general, is very suitable when you have large storage volumes, especially if you're considering consolidating some workloads together, which in case is going to increase your IOPS and storage. Now, with that said, let me quickly sum up some of the key tips that we just looked at. So at a high level, I think understand your workload. Do consider situations where you're not just going blindly and saying, OK, we need more data. Let's just go ahead, create more domains, create more analytic solutions, and just get going. You need to think about the efficiency angle. And so some level of centralization is going to be useful. Consider security features like VPC that we discussed. Do look at S3 as a data lake. Look at the Kinesis data pattern. And of course, definitely think of your bottlenecks as you scale. So I try to keep this fairly concise and limited to key factors that I feel are essential as you build log analytics solution. Now, in the interest of time, I'm going to stop there. I'm going to invite Tommy, who's actually going to walk you through their experiences, how they incorporated some of these principles into their use cases, how they went about building the actual log analytics solution. And hopefully, that is going to give you a lot more insights as well as you think about building your log analytics solution. Over to you, Tommy.
Thank you, Pranav. Hello, everyone. My name is Tommy Lee. I work for Autodesk. I'm a software architect. So today, I'm going to cover the following topics. I'm going to talk about the kind of problem that we are dealing with, what is bothering us, and how are we going to address that problem. Then I'm going to get into some of the architecture, technical stuff, exactly how we build a solution. And then I put some emphasis on the Elasticsearch portion of our solution, how we're going to do that, the kind of things that we have encountered. I would like to share those experiences with you. And last but not least, I'm going to talk a little bit about some of the lessons learned and the things that, that we have acquired through this project. So I just want to give a brief introduction of what we do. So Autodesk, we build software products to help our customer build things or make things. And these are all the things that our customers have built using our product. So it's everything, day-to-day stuff, anything that you use. So a lot of these things are actually built with our products. This is the amount of traffic or end users that is using our product. This is the web scale kind of problem that we are dealing with every day. So our products are built upon a cloud platform. So everything that is compute intensive with a lot of data, these are all centrally managed through a platform. We have a name of it called Forge. So our products work upon that. Our customers use our product, which then depends on the platform. And customers can also build their own apps directly upon our platform. So this is how a typical product situation or the patterns that we're dealing with as our customers are using our product. So a customer uses a product to do work such as I'm going to design a hospital, a skyscraper, or whatever it might be. So most of the time they use our product to build a model, and then they upload the model to the cloud services, which is the Forge platform, to do interesting things, such as I'm going to transform this into different formats so that I can actually view it in a 2D or 3D model at the end. Right? So as the data is being uploaded into our cloud platform, it actually goes through quite a few things behind the scenes. So the gray boxes represents all our microservices in play. They have a lot of relationship to each other. And at the end, whatever we do, we'll end up like turn the model into a view, just like in the diagram that I showed, and the customer will work with it. So this is very important for us, that the customer experience when they interact with us through our product. So if the upload process is completed, but the rendering of the 2D, 3D model is kind of having a delay, it actually impacts our customer, right? So because they're working on projects and they rely on our product and the services to keep going. And at some point, when things goes wrong, the customers become anxious, and then these are the typical kind of support questions that we're dealing with. So it's a tough problem. As we all know, we're working and operating in a highly distributed environment, and we're all familiar with the fallacies in distributed computing. This is the reality that we'll deal with. So rather than try to avoid it, or whatever way that we try to ignore it, we actually have to embrace it. And this is our new reality. So we have to somehow deal with failures, deal with problems, and this is one of the things that we find is very important. So in order for us, right, to help our customers to have an excellent experience using our product, we got to be able to know about what's going on in our ecosystem. So we must have a way for us to consistently collect metrics so that we can do the following things. So these are the three major categories of goals that we want to achieve. So first, we want to make sure that we have a real-time monitoring means, so that when things happen in any part of our cloud platform, we know about the situations immediately, so that we can take actions, right? We can call our teams to support our customers immediately. So the goal is to improve our overall time to detect, the MTDD, mean time to detect. So want to improve in that area. The other part is to support our forensic activity. When an incident happens and we can successfully detect it very quickly. So how do we support our teams to actually troubleshoot where the problem is, what the problem is, and where does it happen? So the quality of the information that we collect, the metrics that we collect, and the way that we can have our teams to use the tools to do the job effectively will help us improve the recovery time. So the goal is to improve the overall mean time to recover. Last but not the least, so all the metrics that we collect, we would like to learn from it, right? Draw insights from it, and so that we can have a continuous improvement. So the better we do in this area, the better off we will improve our product, and then the failure between incidents will become far in between. So we want to improve our overall mean time between failure. So the pain points that we've been going through is like this. So although this has been a while, we have started our cloud journey like 8 to 10 years already. So throughout the entire process, we built a lot of systems. A lot of these are legacy systems, and then they're all in different sizes and shapes. So we do not have a way for us to effectively trace, like in the workflow example that I just shown, like how these things actually relate to each other. So without being able to do so, it's tough to actually troubleshoot problems easily. The quality of data is also a problem. So every team just dump whatever they think is important, which is good to have, But when it comes to let's talk to each other and solve a problem because the customer has a dependency on all these services, then that will become a much bigger problem for us to deal with. So, and because of that, we have problems about the quality of the data, about the timeliness, about the correctness, so on and so forth. It's actually quite hectic. The infrastructure that we have and the solutions that we have built up over the years come to a point where we are dealing with some scalability issue. It's kind of coupled with all the first two problems that I've just mentioned. That makes the ongoing operation and the management of the cost becomes quite bad, right? We also have been taking a tool-centric approach, meaning everything goes to one place and use a tool and rely on that tool to help us solve all the problems, answer all the questions, right? It turned out to be not as effective, right? And the data is kind of locked in a tool, and it's difficult to actually take the data out, and then we can do more of the big data kind of work, analytics kind of work. So it's not efficient at all. So then the overall analytics quality becomes a problem because we have all these incoming, the ingestion path where the data is not accurate, it's not timely. So our teams cannot rely on that to draw the correct insight. And then also we have so many different kinds of pipelines, different CI/CD process, makes all the integration become quite complex, and they're not really compatible with each other. So we have a chance early this year to rethink and rework the entire problem. So the way that we've approached this project is let's tackle this problem from a architecture point of view, right, or a platform point of view. So as a platform, what should we do about it? So as we apply some of the architecture principles into the problem, the first thing we want to do is to make sure we have a very clear separation of concern. And each area, each concern, we have a well-defined responsibilities and interfaces. So by being able to do so, then we will be able to bring in the best-in-class solution to solve a particular kind of problem. And you can actually easily swap in and out different components as we see fit. And we also want to use as much managed services as possible. We have a very small team to start off this project, and we want to focus ourselves on the business problem rather than managing the infrastructure. So the more we use managed services, the better off we will be, because managed less is actually help us to gain more value out of it. We also want to simplify the solution. We don't want to have, say, the ingestion part and have so many different flavors of ingestion combinations. We cannot support all these different mix of work. It's just not going to be scalable, not manageable at all. And we also want to make sure that we have a common taxonomy, common language for all the teams to interact. So we standardize on metrics. So there's a standard set of metrics that we say everyone should use. And then, but we also allow every product and services to extend upon the standard set of metrics to have their own set of custom metrics. So, right. Now, so this is the system architecture that we have built up to this point. So there are 4 swim lanes in this diagram. So they all represent the 4 areas of concern. So the first is source. That's what I call the source, where all our products and services reside. So from the infrastructure point of view, we largely have 3 kinds of implementation. First is EC2-based, classical EC2 applications, which is at the top. The middle one is ECS. We have containers. And then the third one is Lambda, right, serverless. So each of these infrastructure, so we'll have application code running into it. And we provide a SDK, which is called the UL SDK. We call it the Unified Logging SDK. So I'll explain Unified Logging in the next slide. So, but through your SDK, we simplify the notion that you log something, and you also have to figure out exactly how your log data needs to be looking like and structure, and how do you handle the distributed states that whoever calling you give you some information about your entire workflow. How do I propagate things down to my downstream services? So these are all handled through your SDK. As the log data is being collected, so it will be like a move over, right? Transported out from the source to the second swim lane, which is the transport layer. So this layer, we pick the Kinesis DataFirehose as our solution. So the data will be pumping over, and each service will have its own corresponding firehose, and from which we enrich the data as we collect through data stream. So there's a lot of data validation, data enrichment work going on, as well as you can see at the bottom of the second swim lane that we have used Kinesis Analytics. So we can then drive like a real-time, say, with a 5 minutes kind of rolling window. We want to detect like what are the spikes in latency, like the P99 of latency of service, a particular set of API. Will there be any spikes in latency, error rates, things like that? These are all done through this layer directly. We don't have to wait until the data goes somewhere else before we do that. So this live feed through the data stream in Kinesis DataFirehose, we just take advantage of that position. And then we put Kinesis Analytics, we write SQLs in Kinesis Analytics, we have Lambdas that goes with it, and then we calculate all these important metrics. And the metrics will immediately be put into CloudWatch, and then directly consumable through Grafana. We have dashboards for each of the services. And of course, the CloudWatch alerts can also send alerts to our other systems in our operating center, such as PagerDuty, ServiceNow. So this is all kind of connected in some very nice way. Now, from the Firehose, when the data is coming through, we do the immediate monitoring kind of work. But the data will then be immediately put into the third swim lane, which is what we call the shared infrastructure for our storage. And that is primarily based on S3. So with S3, as the data arrives, then we will do some enrichment and other work to turn into the final form. But the data also, as it goes into S3, it actually goes to the Elasticsearch, which is in the fourth swim lane. So the Elasticsearch is actually the important part of this swim lane. So we take advantage of the fact that Firehose manages the indexing workflow with Elasticsearch. We don't have to code a single line of code, but just simply get it done, right? Because this is managed through the relationship between Firehose and Elasticsearch. So we also don't need to take care of the static mapping of the schemas. We simply rely on dynamic mapping and the handshake between Firehose and Elasticsearch is amazingly good. Yeah. So the Firehose will then use the Elasticsearch as the primary destination, and we treat S3 as the backup destination. That's how we can achieve the two goals in one shot, right? So as the data gets into S3, then we will enrich, as I said a little bit earlier, and then this becomes our overall data lake part of the operation, and then the end users can then, based on the particular use case, if I am a forensic team, I can use Elasticsearch, I can use Athena as well to act on some of the data that's been stored over the weeks or months. But then for Elasticsearch, we give them immediate access to the data just happening. So we do not store a lot of data into Elasticsearch. We store currently 5 days of operational data because we believe Elasticsearch is primarily to be used for forensic activities, but we selectively allow data to, some of the indexes to be having a longer retention period, right? So there are things that we feel is important for to create like real-time dashboard on some operational stuff. So those are the things that we rely on Elasticsearch Kibana for us to do it. But the bulk load of the data storage, we rely on S3 as our long-term durable store. So that's overall architecture. So Grafana, as I call out, is our primary dashboarding tool. Make use of the CloudWatch data that comes with through the Kinesis DataFirehose pipeline. So this is one example. This is one of our mission-critical class 0 service. It cannot go down. So the metrics that you show in here represents that particular service, some of the key API. So we actually use Kinesis Analytics as the log data of that service goes through Firehose. We calculate these metrics, and then it shows in CloudWatch and picked up by Kibana, just like that. It's pretty real time, right? So when things goes wrong and if there's a threshold of red line kind of cross, then alerts will be sent, and then the rest of the motion will come into play. We also use Grafana to monitor our own infrastructure, which is the architecture diagram that I just showed you. So this is a dashboard for this infrastructure. And in particular, I'm showing here the way that we're monitoring Elasticsearch using the same implementation. So I want to touch upon a little bit of our approach of handling log record. So now I'm getting into a little bit of a layer 7 kind of discussion here. Now, so as I explained a little bit earlier, so we have a problem dealing with different kinds of log format, and then it's difficult for us to make sense out of different systems log record together. So this initiative, which is called Unified Logging, is trying to address that problem, right? So the way that we do it is to standardize on a log data model, right? Something that is people that we go through years of evolution, come to a point that we feel this is a way of doing it. The way that we do it is through that log data model, we allow annotation. So there has to be a way for us to put additional metadata into the log record so that when we search through the log record, we can rely on criteria based on metadata value. So annotating log record is the key part of the solution of this Unified Logging initiative. We adopt open tracing as our standard, so we don't have to reinvent some of the good work that the community has done when it comes to representing first-class objects, operations, and things like that. So that gives us a pretty good head start in this effort. And we provide SDK support. So we have around 5 major languages in our ecosystem. So each of these, we have a corresponding SDK that each of them are just parity, having feature parity across each other. So we make sure that all the teams that work with us here have their own tools to actually do the job very quickly. This is an example of what a Unified Logging record looks like. So it's in JSON. It's largely divided into 3 parts. So the first part is the part that we call the metadata part, which deals with the distributed tracing states. So you can take a look at the second one, which is the hash span ID. So the hash value here is a timestamp-based kind of hash value, and it's X-ray compliant. So the rest of the headers here, so in the first section, we are able to inject additional states as packages or set of key value pairs that we can also inject and carry along, and each of the log record for the common section for distributed trace metadata will contain those states as well. The second part is the metadata for that particular span. So if you recall in my example, all the gray boxes connecting to each other. So each of the gray boxes, whether participating in a particular workflow, is actually can be represented as a span. So within the duration of the lifespan of that gray box, so the second section represents the metadata of that span. And then the third section is actually the real meat, right, which is the log data, the content that the applications or the service cares about. So this largely is a structure of our Unified Logging solution. So what can we do with this logging data? So if you recall in my architecture diagram, so as the data goes through the Firehose into different stages, at some point we do a lot of enrichment and stuff. So this is one example in the architecture diagram that we can actually make sense out of the log data and do extraction upon the metadata for the distributed states and stuff, and actually can put into X-ray as segments. So with X-ray, we are able to do a graphical service map like this, and we can do a coarse grain, like a understanding of the well-being of our entire Forge ecosystem for the last 24 hours. So which system is actually having a problem, turn rest, and things like that. But we can also do very fine-grained service map because all the metadata that we have put as annotation in a log record can be annotation metadata into X-ray segment. You can actually query those things very precisely, so we can have a fine-grained, very fine-grained service map per user transaction as well. So it's pretty powerful. So how do we help each of our team to easily get onto this solution? So as you can see, there are so many moving parts. If we ask each of the team to work on each of the solutions and build and provision things the way I show in the diagram, it's going to take forever, and no one's going to do that. So we take a simplified CI/CD onboarding kind of approach. So a team just simply needs to do, just tell us a few things, which is at the top right part of the diagram, a little descriptor, that tells about who you are, and there is a what we call a system moniker, which is a label, right? A little taxonomy on our side, identify this is your identity. So when this JSON is pushed to our GitHub, then it will trigger some Jenkins job and generate the repo for that service, and which is in the middle part of this diagram. So, and that GitHub repo is well generated with templates and codes and stuff that the team will only need to define a few things, such as, okay, these are the 5 APIs, and here are the names that I care about. And here's the red line that I want you to keep to track this for me for any anomalies and show up in the dashboard. So you change a few of these things, and then you check it in, and then we also kick off another pipeline in Jenkins to actually do the provisioning for you. So which ends up at the lower part of the diagram, all the Firehose pipelines for your service will be done correctly. And then we also will provision a graphical dashboard for you, and then so all the metrics that you tell us is needed to do will be generated with the corresponding Kinesis Analytics scripts. So, the whole process takes maybe 15 minutes for us to actually provision the entire structure, and then immediately the teams can start playing with it and generate log records, and then they almost, in 15, 20 minutes, they can see the record going through the entire pipeline quite easily. So that's how we do things and onboard all our services team. So now, why do we pick Elasticsearch, right? Amazon Elasticsearch service. First of all, it's a fully managed service, where you don't have to we don't have to have a deep knowledge about some of the inner workings of Elasticsearch, and that's not our intent to do it anyway. So we like this one. It's highly available. It will take care of all the availability issues for us, and we like it. It's quite easy to provision, and the scaling process is a simple point and click or running a simple command line. You add more nodes to it, and it will be done quite handily for us. There's a lot of instance type selection for us, and that is an exercise that we have gone through about our sizing and capacity planning stuff, which are going to come next. So, but it gives a lot of options for us to configure our cluster. We like the seamless integration with Firehose and all the things that about S3 integration, and altogether this is a very well thought out kind of integration solution. CloudWatch metrics integration for our monitoring, which is important. Kibana is part of it. We love it, and it's very cost effective. Now, so the cost effectiveness part of the solution doesn't come easy, right? So we actually have gone through a proper sizing exercise. So this is the template that we use for us to come up with that conclusion. So Pranav explained about some of the sharding concerns. You got to take care of active shards and things like that. Now, this is exactly the exercise that we're going through. So when you do a sizing exercise for Amazon Elasticsearch, you have to think about your ingestion rate, your storage requirement, and then your particular pattern of how you're going to use the service. For our purpose of doing log processing, the definition of active shards is about the amount of data that is going to be ingested into the pipeline in a 24-hour period. So we look at it as the starting point of like 3 terabytes of data ingestion, right? And then from which we determine, okay, so how many shards per index that we will be dealing with. So by default, as you all know, that the default is 5 shards. But some indexes are smaller, so we actually can have a fewer number of shards. So altogether, we do a tally, and then this is exactly how many shards we need. And then with respect to the total storage, which is 2 terabytes as 3 terabytes as a starting point, then we work backwards and forward, like what instance types are actually fitting our purpose. Because the number of active shards determine the number of vCPUs that we need. So we ended up choose like i3 as our instance type of choice. So you can see we might not fully utilize all the vCPU, but because of the fact that we have to deal with the storage requirement, so this is how we ended up being. And as you can see, the other columns here, if our solution scales and start putting more data into the pipeline, the cost of this infrastructure actually is quite growing linearly. It's not going to be exponential. So to us, I think this is a great solution for us. Right, so Kibana definitely is one of the things that we have adopted. So there's so many teams that build their own dashboards for their own purpose. So it's like a very good like a feature that everyone likes. Now, so this is a lessons that we have learned, right? We started small. We want to keep the ball rolling quickly. So the first thing that we did is to put everything into one index. So we have our services and products are onboarded gradually. So at the beginning, let's keep it simple, put everything into one index. But very quickly, you find out it's not going to work. You can see from the dashboard here, so the CPU utilization actually spikes up just like that, right? So it's like at 80% or above, as Pranav showed in one of the slides, that definitely is not a good sign. So when it happens, everything stops. So you cannot do further indexing, query is going to be extremely slow, no one can do anything, right? And because of that, we cannot onboarding more services, everything got stopped. So that's a bigger problem. We also have found out that the way that we put everything into a single index, so as all the teams ingest their log record, there's a lot of JSON, and there's a lot of dynamic types of JSON, like maps or collections and stuff like that. So we are not aware of the fact that when everything adds up together, it exceeds the 1,000 fields limitation. So Elasticsearch index, by default, is 1,000 fields. If you exceed that, there will be performance problem. So we encountered that this particular situation, like maybe a few months into the whole execution of the project. So there are a couple of options that we consider to mitigate it. Option number one, we put up an index for each service. So we've actually found out that it is a pretty good deal for us because most of the services will have definitely much less than 1,000 fields. Some of the bigger ones will have 200 or 300 at most. So this could be a good thing. And we can actually do query upon an index directly rather than having a big index and every search you've got to go through all the records. So it's not. So we believe it's going to give us better efficiency. But at the same time, it increases our complexity in terms of the provisioning process. So, but we can, because of the automation work, maybe it's worthwhile for us to do so. Not everybody needs to know what's happening behind the scene after all. Option two is to keep single index, right? But to set the max field to a bigger value, like 2,000. But then we know that this is an anti-pattern. It's going to be impact performance. But what if we keep growing and grow beyond 2,000? What are we going to do, right? So it doesn't work. It won't scale, and we can't do it like that. Option three is about, then again, keep a simple index, but make it operationally friendly. So such as we define maybe 50 core fields, and then we have another 200 like custom fields that you can do your own mapping. So operationally, definitely it's good, right? So we can pretty much control the blast radius, and it won't actually go beyond the limit. But at the same time, the usability sucks, right? So how do you do a query on some indirect referring to some fields like that, so it won't work? No one will use the solution. So that's why we go for option number 1. We do this thing, right? And there are other things that we have learned along the way about managing the sizing of the cluster as well. So as I said, by default, there will be 5 shards per index. So for the most of the indexes that are around 250 gigabyte, it works. And we also stick to the recommendation that we use like a 50 gigabytes per as a default shard size. So because of that, smaller indexes, smaller services, we do a customization that they will have only 1 shard. So anything that is on a daily ingestion basis, less than 50 gig, will 1 shard for those kind of indexes. And we did tons of performance load tests to make sure some of the hypothesis theories kind of hold. We have a set of regression performance load tests that we keep running. So, at this point, we feel pretty good about our current status of things. You can see this is the current state of our stuff. So most of the time, the CPU is around 40 to 50%. So we are not underutilizing things, and at the same time, we are not actually making things too crazy. So I want to wrap it up by sharing some of the overall lessons that we've learned. So the entire initiative started up small. We are a relatively big company, but we take a little bit of a startup kind of mode in handling this project. So we go through some inception phase, a little bit of incubation to build an entire end-to-end to make sure that this thing works, and then we acquire enough funding to build the entire thing completely, and then we're now getting into the aggressive adoption phase. Now, so the whole unified logging and all these things can only bring forth the best value if there is a widespread adoption in a company. So the management support from the top down, making sure everyone aware of the value is important. And we are still in the process of making sure bringing in a lot of different services on board. We have a lot of services. Sizing is important, so, and we partner up early with our finance team to make sure that our solutions are well within budget. So it's quite easy for us to put up something, especially in Elasticsearch, that you don't understand the relationship between cost, performance, and the infrastructure need. You can easily blow up your budget. So I think it's important to be cost aware at the beginning of this journey. Be agile, just like any other project. We don't overdo, and we encounter problems, as I explained to you, and then we tackle it. There's always things that we don't know that we don't know, and those are the surprises that we know that will come at us at some point in different way. We just have to prioritize the risk, divide and conquer. Use managed services. We don't attempt to build and manage these things separately other than using AWS and managed services. We have a small team, and actually it's the best deal for us. Partnership with the AWS team. These guys are very helpful every step along the way, and we feel grateful about that. So that's all I have prepared for today, and thank you very much.